Dear students, we have seen the reactions like that compound, that is solulysis of cis and trans compound, that is a 4 tertiary butyl cyclohexyl tosylate and trans tertiary butyl cyclohexyl tosylate. Okay, this is a trans one and this is our cis compound. Okay, in this reaction solulysis we have carried out, and the transition state for this reaction was it loses OTS, okay, departs OTS, and we obtain the carbocation like intermediate. Then solulysis will be takes place. Okay, in this reaction it is as like a SN1 reaction. Okay, in SN1 reaction carbocation is formed, and then our if suppose we have OC acetate ion is attack, or OH minus ions will be takes place. Okay, that is solulysis. Okay, water is there, then solulysis, OH minus attack on this case. Okay, therefore in this case we have seen that the that is the crowded substituent react faster than the less crowded substituents. Okay, it depends upon the transition state and the energy, ground state energy and transition state energy, okay, excited state energy and the energy of activation. Okay, energy of activation for this molecule was less, therefore it react faster than the other isomer. Okay, this is when you see this is a type of like SN1 reaction. Okay, carbocation form, then nucleophilic attack takes place. Okay, that first reaction we have seen attacking nucleophile on a compound. Okay, the second example for this we have seen the symmetric attack of on molecule. Okay, suppose we have that particular molecule. Okay, first was the cis isomer and second also was the also its second isomer, that is a trans isomer. Okay, this compound we have seen, and common on same nucleophile we used, that is I minus depart, and in this case also I minus departs, and the same nucleophile we have used for these two isomers. Okay, this is a SN2 reaction. Okay, we seen SN2 reaction, and its intermediate, that is a departing group and attacking group gives like that intermediate. Okay, in SN2 reaction departing group and attacking group is simultaneously bond breaking and bond making takes place in nucleophilic bimolecular nucleophilic substitution reaction. Okay, in this case also we have decided the crowded substituent or oxyl substituent react faster for this reaction. Okay, then we are comparing our ground state energy and the excited state energy of activation for this molecule was less. Okay, we have already discussed. Then we have seen that is a symmetrical SN2 reaction, because our attacking group and leaving group is same. Okay, therefore the energy of it is higher and energy of this is lower because it is a stable isomer, and the same transition state is there. Therefore for this our cis isomer, the transition state energy of activation is less. Therefore that molecules at SN2 reaction was reacted faster. Okay, though it is acyl one and it react faster than the equatorial isomer. Okay, its activation energy is higher for our cis isomer. Okay, Then we have seen the unsymmetrical attack of nucleophile. Okay, unsymmetrical attack means first example we have taken was the 4 tertiary butyl cyclohexyl tosylate. Okay, that is cis isomer was there, and the another was the trans isomer. Okay, these two compounds, and then 4 tertiary butyl cyclohexyl bromide, or the second example. Okay, that example we have seen. Okay, therefore the energy of this is the higher and energy of this was the lower. Okay, like that we have described this molecule, and if our nucleophile attack is from that side and nucleophilic attack is from upper side. Okay, for this compound you found that the it is a unstable one. Okay, it is a bigger group. Okay, it is big group and is smaller, and nucleophile is if considered as smaller, and this is a smaller group, and our nucleophile is the okay, we particularly pH okay, thiophenolate okay, thiophenolate ion we have used as a nucleophile. Okay, this attack from, because it is a bulkier acyl position group, minus HPH is attack from acyl. Okay, then by comparing its energy, we have decided which is the react faster. Okay, now we have in this lecture the cyclohexamer, okay, one of the reaction, and particularly we have discussed this in this our lecture. Okay, cyclohexamine when treated with HNO2. Okay, H plus and HNO2. And then nucleophilic attacks will take place on this molecule. Okay, when we add the H plus HNO2, the first role of H plus HNO2 to convert the NH2 into diazonium ion. Okay, diazonium, when you add in this, if amine is there, primary amine, you add the HCl, and if you add your nitrous acid, it gives the N triple bond N. Okay, this is your diazonium ion. Okay, same will happen in this case. When you add HNO2 and H plus, first you obtain this R is the substituent, you obtain the diazonium ion. Okay, in both cases you obtain the diazonium ion. Okay, when you and then in nucleophilic attacks, okay, OH minus, it takes place, the alcohol obtained when your NH2 group is at equatorial, the alcohol obtained, okay, N2 replace and that OH minus attack to this side, the alcohol obtained is in this, if your NH2 is at equatorial position, the alcohol obtained, that is cyclohexanol obtained, is at equatorial position. Okay, when you try to attack OH minus, that is hydroxyl ion nucleophile on this side, you found that this side is the there is a equatorial position, diazonium ion is that is a crowded site. Okay. Therefore, OH minus attacks, how it is give the equatorial, N.H2 gives the equatorial diazonium ion, and how it is possible to give the at equatorial position OH. Okay. That is retention in configuration takes place. It means the retention in configuration. Retention configuration means the configuration is present in this reactant molecule. Okay, NH2 is at equatorial, it is preserved in the product, OH is also equatorial. Okay, that is a nucleophilic attack. Therefore, NH2 at equatorial, it maintains the OH at equatorial. This means the retention in configuration takes place. Okay. And retention in configuration in nucleophilic reaction means it is a OH minus attacks on this molecule takes place via cyclic intermediate. Then and then you obtain you preserve the retention in the product. Okay, when you add this side is the crowded, when you add the OH minus hydroxide minus in this side. Okay, by observing the molecule, you can find that you should obtain the acyl OH, but actually you not obtain the oxyl OH. Okay, it first means that there should be a cyclic intermediate. If retention is preserved or the configuration is preserved. Okay, therefore OH minus attack should be attacked from that side. Okay, that side. Then and then you obtain the equatorial product. Okay, therefore retention is preserved when nucleophile attack takes place. Okay, in this case it means it is a SNI reaction. Okay, that type of reaction is when retention is preserved in product, that is the SNI reaction. Okay. Therefore, such reaction, SNI reaction, is perform or retain its configuration by cyclic intermediate. Okay, therefore when attack OH is not attack on that side, OH attack on this nitrogen, and this will be your positive charge neutralized on this nitrogen. Okay. Okay, therefore you obtain the such situation. Okay. Okay, now this will attack at that side. Okay, and this breaking takes place simultaneously. Okay, this will give the reward bond to makes the N2. Okay, therefore at such cases you obtain the equatorial OH. Okay, this is a cyclic intermediate. Okay, this is cyclic intermediate. Okay, this alcohol is obtained via cyclic intermediate. Okay, firstly we have the equatorial NH2 by adding the nitrous acid and H plus ions, it is converted into N2. Okay, that is a diazonium ion. That N2 is called as the diazonium ion. If N2 plus is there, it means it is a diazonium ion. Okay, by adding HNO2 you convert the NH2 into diazonium ion, and this side, equatorial side, you found it is a crowded one, then therefore OH minus attacks should be from X side. Okay, but this not attack like that, attack is not takes place here. Okay, because at the product you found the retention in configuration. Okay, such situation only found in the SNI reaction. Okay, it is also a kind of nucleophilic substitution reaction. In this reaction, retention in configuration takes place. Okay, therefore retention, if there is a retention in configuration and nucleophilic substitution reaction is there, it means definitely it is a SNI reaction. Okay, and SNI reaction, if it is there, then it means there is a cyclic intermediate present. Okay, therefore this molecule react through the cyclic intermediate and give the equatorial alcohol. Equatorial amine gives the equatorial alcohol. Retention in configuration is found there, and our that type reaction is the SNI reaction. Okay, this is first case when you have the NH2 is at equatorial position, but when NH2 is at axial position, when NH2 is axial position, then you obtain the the equatorial alcohol. When NH2 is at equatorial, there is a mixture of product is obtained. Okay, equatorial alcohol is also found there. Axial alcohol it also gives, or it also gives the predominantly olefin. Okay, this is olefin, hydrogen is olefin is obtained in this case also. OH equatorial is also obtained, axial is obtained. Okay, there is a mixture of compound is product is obtained when it is at axial position. Okay, you found that easily OH minus, if you add the HNO2, it convert into like that. Okay, N2, the easily OH minus is attacked from that side. Okay, therefore you can obtain the equatorial one, but actually this is not found in this case. Okay, in this case it is axial, it is hydrogen is axial, it gives N2 is removed. This case olefin is also exclusively obtained, and also obtain the axial OH and also obtain the equatorial OH. But when equatorial NH2 is there, in this case you obtain the equatorial alcohol if amine group is present in cyclohexyl ring. Okay, this is all about the SNI reaction which is found cyclohexyl amine. Okay, now we have seen the SN1 reaction, SN2 reaction, and also SNI reaction. Okay, at this case we found that the steric assistant was there, but some reactions it requires the special stereoelectronic situations. That reactions are elimination reaction is there, or neighboring group participation is there. This reaction requires the special stereoelectronic situations. Then and then this reaction is happen, which product is obtained, you can or which substrate or which reactant is fast react, we have to decide when that substrate maintain the stereoelectronic stereoelectronic requirement. Okay, so suppose we have elimination reaction, E2 reaction. Okay, E2 reaction, okay, simple one. How we have the reaction? Okay, that is a bromine is there, hydrogen is there, and we add the base. Okay, OET minus is the base, and in elimination reaction it pick up the hydrogen. Okay, extract the hydrogen, and like that your group is the removed. Okay, this happen in a single step in a elimination reaction. Okay, therefore in this case bromine and hydrogen should be anti to each other. Then an elimination reaction takes place. Such situation is also you found in neighboring group participation. Okay, if neighboring group participation is like that, okay, it is a living group, and okay, like that you have the X is the substituent and which is having the lone pair. Therefore this X and OTS is also should be the axial to each other. Then like that neighboring group should be possible. Okay, in this reaction you found that the stereoelectronic requirement is the living group and the departing group should be anti to each other and the periplanar to each other. Okay, when we consider the cyclohexyl ring, in cyclohexyl ring, if suppose we have three situations. Okay, first situation that is your living group. Okay, this is living group and this is our hydrogen, if suppose is the departing group. Okay, like that you obtain elimination takes place, you add the base, elimination takes place. Second situation, okay, like that situation is there. And third is the like that our X and the hydrogen. In cyclohexyl ring, your living group and departing group should be trans to each other. Then elimination reaction or the your NGP reaction are like that reaction where stereoelectronic requirement is there. Okay, when E2 reaction is when we perform in a cyclohexyl ring, there is a stereoelectronic requirement is the your departing group and your abstracted group or living group and our abstracted group should be axial to each other. Okay, in this case also they are the trans to each other. Okay, trans situation is not required. You require firstly trans situation, but which trans? Both group, living group and the abstracted group will be at axial to each other. Then E2 reaction and NGP is possible. Okay, in this case they are trans but they are equatorial. They are not axial. Okay, axial is the stereoelectronic requirement for cyclohexyl ring when there is a elimination reaction takes place. Okay, then in this case is also E2 reaction is not possible. When it is possible, when that living group should be at the axial one and this abstract base, by using the base we abstract the hydrogen. This hydrogen is also from the axial to each other. Then okay, this situation is also E2 not possible and this situation also E2 or NGP is not possible. Okay, therefore for performing elimination reaction in cyclohexyl ring you should require your departing group and the abstracted group axial to each other. Okay, we have an example that is a neomethyl tosylate. Sorry, neomethyl that is a neomethyl group is looking like that. CH3 is there. Neomethyl chloride. Okay, chlorine is there. And isopropyl group is there. Okay, one is the neomethyl chloride and other is the methyl chloride. Okay, in this case is the hydrogen one. Remember that. Chlorine is there. Okay, in this case this is the equatorial axial, and in this case it is equatorial, it is also equatorial, and this hydrogen is also axial. Okay, neomethyl chloride react 200 times faster, okay, than the Okay, elimination reaction, new methyl chloride 200 times faster than this molecule. When one molecule is react, 200 molecule of new methyl chloride is reacted. Okay, why this elimination reaction is found in fast in new methyl chloride? Because it maintain the stereoelectronic requirement. Okay, stereoelectronic requirement for an elimination reaction. When cyclohexene ring is there, we have discussed it should require the that hydrogen and chlorine should be exiled to each other. Then and then that elimination reaction will be faster. Okay, in this case, in first case you found that when you draw it's in cyclohexyl form, and when you draw this in cyclo chair form, you found that this group is the equatorial. Okay, we have seen the equatorial at the dash means or pointed means it is the back side. Okay, that is the below side. The chlorine is at axial. Okay, we shown the chlorine is axial. Okay, first 2 3 4. Okay, 1 2 chlorine is axial. This group is at the equatorial. Therefore, next to chlorine we have shown that group. This is the equatorial one. Correct. And that hydrogen is axial. Correct. 1 2 1 2. This is at the 3 position. Sorry, chlorine is at 3 position. Okay, chlorine is at axial 3 position, and this bulkier group is the equatorial. Okay, the bulkier group equatorial. Hydrogen is at the axial. Okay, now for this case, CH3 is at the equatorial 1 2 3 4. Chlorine at 3 position is at the equatorial of chlorine. Show the equatorial. This is equatorial one, and that hydrogen is the axial one. Okay, you found that this easily undergoes the elimination reaction, and you found that your departing group or leaving group, chlorine is the leaving group. Chlorine in this molecule you found the at equatorial, and chlorine in this group found the equatorial, and it is having the at its near carbon. Okay, 1 2 position carbon, there is a 2 axial group is there. Therefore, it maintained the leaving group also at an axial position, and this abstracted group by the base is also axial position. In this case, you found that near to this that hydrogen is axial, but this is chlorine is there at the equatorial position. Therefore, you found when you compare these two compounds, the stereo electronic requirement. Okay, what is the stereo electronic requirement for elimination reaction, E2 reaction? The leaving group and the abstracting group should be axial to each other. Then and then this is happening. Okay, therefore it's your base pick up this hydrogen, then like that you obtain the product. Okay, the product is obtained. Okay, like that. Okay, for sake of convenience, we first write in chair form because double bond chair form is the unstable one. Okay, therefore double bond chair form is not found. Okay, for sake of convenience, we write like that. Okay, therefore you obtain the compound. Okay, this is equal to like that. At that position, double bond is there. 4 position there. You have the CH3. Okay, there in this compound it has the 2 hydrogens. Therefore, it's 2 way it can use the product, but it gives the major product. This product. Okay, this hydrogen is majorly or mostly pick up, and you obtain the Z product. Okay, Z product. Okay, Z product means the product is obtained where most substituted double bond is there. Then and then this product is obtained. Okay, in this case you found that there is a double bond is obtained. at the more substitute. Okay, this double bond is less substituted because there is hydrogen. This group is common. For this group there is a substituent is there. Okay, CH3, this propyl group is a substituent. This is the most substituent double bond. Therefore, instead of this you obtain the major at the most substituent double bond. Okay, therefore in this case product is obtained more substituent, and this is the Stereo rule. In an elimination reaction, most substituted double bond is obtained. That is our Stereo product or Stereo product. That is a Stereo product. In this case, you found that the molecule is not at that position. It is not possible to an elimination reaction takes place. Therefore, for the elimination reaction, if you add the base, the flipping is takes place. Okay. After flipping, you obtain the stereoelectronic. Its stereoelectronic requirement. It can be fulfilled, and then it's maybe react. Okay. After flipping, ring is looking like that. Okay. At that case, your CH3 is at acyl 1. Okay. After flipping, equatorial will be acyl and acyl will be equatorial. Okay, then your next is the hydrogen. To this chlorine, 1, 2, 3 position is the chlorine. Chlorine will be takes the acyl position, and after that you have the propyl group there. Okay, in this propyl group, hydrogen is the equatorial. Okay, you found that after the flipping, the stereoelectronic requirement is fulfilled. Therefore, leaving group, that is acyl 1, and hydrogen is also acyl 1. Okay, therefore leaving group and abstracted group by the base is also acyl. Okay, it abstract the hydrogen, and then like that departing. Only one product is obtained in this case. 2, 3 position double bond is obtained. Okay, in this case CH3 is there. 1, 2, 3 position double bond is there, because only one near to this hydrogen is equatorial. Therefore acyl equatorial situation, no elimination takes place, and acyl hydrogen is there, acyl chlorine is there. For stereoelectronic requirement is fulfilled in this reactant, then this type of elimination takes place in this reaction. Okay. Therefore, the compound which maintain the stereoelectronic requirements, okay, that is elimination reaction, if takes place in cyclohexyl ring, then stereoelectronic requirement is your departing group and abstract ring group should be acyl to each other. Okay, another example of this category is that is chlorine. All the chlorine at the equatorial one, that is our hexachloro cyclohexyl. Okay, hexachloro is there. Okay, this is the beta isomer. Okay, for this compound is having 8 isomers. Okay, different type of isomer. Okay, suppose in one compound one is that the acyl one. Okay, like that. Okay, different types of there are the stable isomer. Okay, 8 stable isomers is having for this compound. Okay, if suppose 2 chlorine is at the acyl ones in say second one. Okay, like that. Okay, like that there are the, if it is chlorine and then it is chlorine. Okay, like that there is a, okay, like that there is a 8 isomer possible for this molecule. Okay, and among the, okay, it is having, it gives the faster elimination reaction. There is also acyl one, it gives the faster elimination. Okay, those isomers which is having acyl chlorine and the acyl hydrogen, this give the fast elimination reaction. But when one of the isomer in which all the chlorine is at the equatorial position, okay, all the chlorine is at equatorial position, therefore this beta isomer reacts very small. Okay, it is very, okay, its rate is 10 raised to 8 less than the, okay, when the one molecule of other isomers is reacted, then it's okay, 10 raised to 8 molecules of the other isomer reacted, it reacts only one. Okay, it reacts only one. It is very slower than the 10 raised to 8 quantity, it is slower. Okay, now therefore in this case you found that when you carry out the elimination reaction, okay, therefore hydrogen, okay, therefore that hydrogen acyl, this is equatorial. Therefore in this case no chlorine and the hydrogen, okay, that is a leaving group and the abstracting group, one is that is the equatorial, one is the acyl one, therefore not possible. Okay, not elimination reaction is the possible. And if you after the flipping you obtain, okay, suppose you have obtained after the flipping all your chlorine should be at the acyl one. Okay, acyl, after flipping acyl will be equatorial and equatorial will be acyl one. Okay, you found that all the chlorine is at the acyl position, and this is a very unstable situation. And if though it flipped up, but no hydrogen, you found that no single hydrogen is at acyl. Only chlorine is at acyl, but the abstracted group, that is hydrogen, not equatorial. Although if you flipped it, after flipping you not obtain also acyl leaving group, and the abstracted group is not at the acyl one. Okay, the stereoelectronic requirement for an elimination reaction is there should be departing group and the abstracting group should be at the acyl to each other. Okay, in this reaction, up to this lecture only we have seen the such type of reaction. Okay, that is a stereoelectronic requirement. Is those compound maintain the stereoelectronic requirement, it react the faster than those not maintain the stereoelectronic requirements. Okay, some other reaction we will see the next lecture. Thank you very much.